Hello and welcome to the Unit 9 review. In Unit 9 we talked a lot about exponents, and so that's what we're going to be looking at today, are some exponent problems and see if we can, kind of give you an idea at least of what you're going to be doing throughout this review, and hopefully it helps you out quite a bit for the test. So, we've done this before, this review video, so you should know what we're looking at here. And just remember that I'm not going to do all the problems. I'm going to do one or two out of, definitely two out of some of the bigger sections. But for the first two sections, I'll do one in each one just to give you an idea of what you're doing. So, write the following using exponents. I'm going to go ahead and look at number 2. So at number 2, there's actually two different ways to look at this. I have 1/2, and I have 1/2 5 times. So I could say that that's 1/2 to the 5th power. Okay? If you wanted to, if you looked at it this way, well, on top of this fraction I have 1 5 times. You could say that it's 1 to the 5th. And on the bottom I have 2 5 times. You could say that it's that also. Okay? Obviously we prefer the 1/2 to the 5th a little bit more than this one. But this one's just a more descriptive way to write that. Okay? Excuse me. Looking at the next section, I'm going to go ahead and do number 5. And when we're writing without exponents, remember, if the exponent is positive, you're just writing it out. If the exponent's negative, you're going to go ahead and put 1 over that expression. Okay. So let's look at the first one. So we have 4 3s. I'm just looking, or sorry, 3 4s. I'm just looking for you to undo what you did in the step or in the section above. And then I have 5 x's. 2, 3, 4, 5. And that'll be your answer. Okay? Let's go ahead and look at the next section. I'll do a couple of the problems out of this. And really, we're just looking at simplifying these expressions as much as we can. Hopefully getting it to where maybe there's only 1 exponent or 2 exponents. But definitely simplifying it using the rules that we've practiced. For starters, I'll look at number 11. So in number 11 we have a power raised to a power, and whenever I have a power raised to a power, I want to multiply those exponents. All right. So that's the same thing as saying 3 to the 3 times 2. 3 times 2 is 6, so we would say that's 3 to the 6th. You could figure out what the number is on, for that problem if you wanted to, but I'm not expecting that you do that. I think that's a good enough answer. 3 to the 6th power it isn't something that's out of our league, but it's just as easy to write 3 to the 6th, and it shows that you know the knowledge that I'm expecting. Okay? Let's look down below. I'm going to look at number 16. Okay? Now in 16 I have I have a coefficient variable exponent, coefficient variable exponent. There's multiplication in between, so it's really just one string of multiplication. I treat numbers like numbers, so 4 times 3, that's 12. M to the 0, anything to the 0 power is just 1. And m to the 3rd there. See, the mistake a lot of people will make is they'll think, oh, that 4m is raised to the 0 power. It's really only 0, or sorry, it's really only m that's raised to that 0 power, so the 4 doesn't go away. Just that m in that part of the problem. Okay? And let's look at number 19, a problem with negative exponents. Okay? Now, I'm not going to deal with the negative exponents quite yet. I'm going to remember I have a power of a product in here, and I'm going to distribute that negative 3 to each one of those. So that's going to end up being 2 to the negative 3 times m to the negative 3 times negative 3. Okay? So we're multiplying those powers there. That's a little bit of product rule inside there. And now I'm going to go ahead and just simplify this part here. You may combine these next two steps as one. I traditionally would, but seeing as I'm trying to, kind of go step by step for you so that you can see maybe if you made a mistake, where you made that mistake at. So m to the 3 times 3, that would be 3 times 3 is a positive 9. Now 2 to the negative 3, if you remember, any negative exponents go below the fraction line. There isn't one there right now, but we can put it there, saying m to the 9th over 2 to the 3rd. You could leave it like that, or you could say m to the 9th over 8. Either one works for me. Let's go ahead and turn the page and look at the next set of problems. Okay. There's a lot more of these. This is mainly what we did in this unit, is we dealt with all the different properties of exponents. So I'm going to do probably 2 more here. I'll do one of these division ones. Let's look at this one right here, number 24. I have x to the negative 3rd over x to the 3rd. Okay. Well, that negative 3rd, x to the negative 3rd, needs to go down below. So on top, I'm just left with 1. On the bottom, I have x to the 3rd, x to the 3rd. I can simplify that because I have like bases. So that becomes x to the 3 plus 3, which is 1 over x to the 6th. Some people might think that it's easier to write negative x to the x to the negative 6th instead of 1 over x to the 6th, but I want all exponents to be positive. Okay. Let's go ahead and look at one of these. If you remember back from the section, they're kind of the bring the pain problems. I'm going to look at number 28. All right. So for number 28, I'm going to go ahead and start with this set of parentheses here, because I know that I'm going to have to take that 4 and distribute it inside. So let's leave the top. I have 2u to the negative 2, v to the 4th. Okay. I'm going to leave this part out in front here, so that's u to the 3rd, v to the negative 3rd. And this will get rid of my parentheses, so I'll have u to the negative 4th and v to the 8th. Okay. Now, one thing you could do is you could start taking your negative exponents and putting them up top. I'm going to go ahead and simplify the bottom one more step to where I only have one u and one v to some exponent. So I have u to the negative 2 up top, v to the 4th, and on the bottom, this is a u to the 3rd and a u to the negative 4th. Remember, we're adding those to get u to the negative 1. V to the negative 3, v to the 8 is going to simplify to v to the 5th. And now we can go ahead and move it to where I only have positive exponents. So this u to the negative 2 needs to go down. And the u to the 1 needs to go up. Or sorry, negative 1. So we're going to have 2u, v to the 4th. And on the bottom, basically I just traded where these u's were because I wanted them positive. So that's u squared, v to the 5th. Okay. Now I'm going to use my division property where I'm subtracting those exponents. And really what that means is I have 1 u up top and 2 down below. The 2 is going to stay there. Okay. And so 1 u on top, 2 down below, that's going to simplify to 1 on the bottom. And then when I have the 4 up top and the 5 on the bottom, that's going to simplify to 1 on the bottom. So we get 2 over uv. That's a lot easier than looking at this, and honestly, it's the same thing. That's why we're working this simplification, because it's a lot easier to look at this than that big monster. Okay? Let's look at the next couple sections. We're dealing with scientific notation. So when we're dealing with scientific notation, remember, you have to kind of know what you're doing in order to get there. You could use a calculator and just turn your calculator into scientific form and have it spit out the answer. But it's important that we know what we're doing. I don't want to look at the first one. That's kind of too easy. I don't want to take all the easy problems away from you. Let's look at number 32. I'm moving the decimal 1, 2, 3, 4 places. So a lot of times I'll put a little note there that I'm moving it 4 times. So that's going to be equal to 8.43 times 10 to the fourth. And remember, the way I think of it is that I want a number a lot bigger than the 8.43, so I want to multiply it by a positive exponent power of 10. Okay. So let's go ahead and look at the next couple. And in fact, let's go ahead and look at number 38. I'll take the hard one from you. Whether it's the hard one or not, I don't know. But remember, what I do is 4.96, and then I'm going to move the decimal. Since it's a negative, I know that I'm going to have a very small number, so that means the decimal is going to be over here somewhere. Let's go ahead and move it 5 times. 1, 2, 3, 4, 5. So I have a decimal, 1, 2, 3, 4 zeros, and that'll be my answer, 0.1234496. Okay, always write it twice because the first time you write it can be pretty ugly. If you remember on the next sections, I told you, an easy way is just to grab a calculator, and that's what I would do. So when I'm using a calculator, I want to make sure that I go and turn it into scientific notation. And I'm just going to type in what I have, 8.2 times 10 to the negative 6th. And I'm multiplying that by 9.3. 9.3 times 10 to the negative 2nd. And I'm left with 7. Kind of tough to see in that light. 7.626 times 10 to the negative 7th. So we get 7.626 times 10 to the negative 7. You could use your properties of exponents if you want to, but there's usually going to be one little issue when you're multiplying the 8 times the 9. You're going to have to move that decimal one more time. Okay? Let's go ahead and look at the next set of problems. Okay, again, most of these are just plug them into your calculator and see what it gives you. Or using the properties of exponents. I'm going to go and use the properties of exponents on number 44. So in this problem, I'm going to be distributing the 5 to both of these. Okay, so I'm going to have 6 to the 5th times 10 to the 6th times 5. It's important to figure out what 6 to the 5th is instead of just leaving it like that. And I need to turn this back into standard notation. So I get 3 sevens and a 6 times 10. 6 times 5 is 30. Okay. And then remember, I need to move my decimal 3 more times. So that's 7.776 times 10 to the 33, because I moved my decimal 3 more times. And that's my final answer there. Again, you can pick whatever way you want to. If you know how to use a calculator to help you, then do that and make your life easy. Alright, let's go ahead and look at this next application problems. Remember, I'm not going to do the problems, but I can help you set them up. For these, we have area of rectangles, and area equals length times width. Alright, so like in this problem, you're going to be just going area equals the length would be 4 to the 3rd times 4 to the 2nd. And you're going to be working with the exponents on that. Okay, shouldn't be too bad. And on the next two, you're going to have to distribute and see what happens to your exponents as well. Let's look at the volume problems. So for volume of a cube, it's going to be volume equals, since it's a cube, it's actually the same size, the same length on each one of them. You should notice that on the problems. But you can just say that it's length times width times height. That would work as well. So like on this one, you're going to be going volume equals 3 squared times 3 squared times 3 squared. If you wanted to look at it the other way, it would just be one side cubed. And you can check that when you do that, 3 squared cubed, you're going to end up with the same answer on those two things, because these are saying the same exact thing. Okay. In the last problem here, you're just ordering these from least to greatest. So it might help to turn some of the ones that are in scientific notation into standard notation and then order them from least to greatest. Hopefully they're not in order already. I don't think they are, but just make sure you turn them into standard notation, and then you can compound them. So good job on the review. Make sure you get all the problems done, get them checked, and then good luck on the test. Have a good day.